everyone, how are you? So I was asked to talk to you today about asteroids and near-Earth objects and other things in the solar system. So I just lumped it all into one large encompassing topic of small stuff and small stuff of the solar system. But I think what you really wanted to hear about and the question on your mind is, will a huge asteroid hit the Earth? So I will discuss that as well, in addition to what else is out there. So what is the small stuff? Small stuff largely refers to planetesimals, which are very small rocks, and comets, which are largely ice. So we have rocks and ice. And these are left over from the formation of the solar system. Some subcategories, an asteroid is something that's really big. But a meteoroid is a much smaller asteroid. Typically the size of less than a meter, but there's not really a hard and fast rule about that. A meteor is a shooting star, something that's falling through our atmosphere and getting really bright. Can be any size, even the size of a grain of sand. And then a meteorite is something that has landed on Earth, so something you can find and pick up yourself. So there's just a couple of types of meteorites that you might find if you go out hunting for one. Most of them are stony, so they look like a normal Earth rock. So these are really hard to find since they look like a normal Earth rock and hard to tell that it's a meteor or a meteoroid, I should say. But they might have crystals in them. The formal name of a crystal is a chondrule, but they might have this kind of crystalline structure. And these are some of the oldest rocks we know of in the solar system. We have found some meteorites that are 4.5 billion years old. So really forming right at the beginning of the solar system. And then there's iron meteorites, and these are ones that you'd probably more likely find. They look a little weird. They usually have kind of a pitted appearance. And then some really rare ones are maybe a combination of the two, where they have some stony material and also some iron material. But you can go out and find these yourself. So here's an example of some iron meteorites. They're usually very black because they've charred going through the atmosphere. So they might have a black outer layer appearance. And then if it's an iron one, it will be magnetic. So if you see a weird looking black rock, get a magnet and see if it sticks to the magnet. And if it does, there's a high likelihood that it might be a meteorite. So you can go out looking for these yourself. So we have many spacecraft that have visited these asteroids, and some even have moons. So there's Ida and Dactyl. And you can see they're all kind of lumpy, bumpy. I call them potato shaped as a general descriptor of these. So I'll talk about a few. But the big one I want to talk about, of course, is Lucy, which is launching October 16th. And if you've seen talks by me before, you've seen me talk about Lucy already. But it is launching in October and it's ready to go. And this is going to go visit several asteroids that are out by Jupiter. And these are really interesting because these are kind of the primordial chemical time capsules of the beginning of the solar system. So this is going to give us a lot of information about how planets, asteroids, comets, the giant planets, everything formed. So stay tuned for that. Another mission was called Dawn, and that went and visited Vesta. Vesta is the largest asteroid in the solar system. It used to be Ceres, but Ceres was elevated in status to dwarf planet. So Ceres is now a dwarf planet like Pluto, which means that Vesta, I keep calling it Vesta. Vesta is now the largest asteroid in the solar system, and it has this weird bump structure. And we think maybe something collided into it when it was still hot and molten and just stuck like two pieces of Play-Doh sticking together. And you may have heard about our first known interstellar object, Oumuamua. And Oumuamua translates to a messenger that reached out from the distant past. And we think it has some structure that indicates it might be comet-like. But we really have no idea where it came from, except that it definitely came from a different system that got kicked out of its own solar system and then traveled to us. And went zipping around the sun, and now it's going off to another system somewhere else. So comets so that's rocks. segueing into comets, we have two resources of comets, either the Kuiper belt or the Oort cloud. The Oort cloud is huge. It's almost extending all the way to Alpha Centauri, which is our nearest star system. So it's a big repository of just really icy bodies that are really far away from the sun. And if another star drifts by, it can disturb their orbits gravitationally and kick one of these icy bodies into the inner solar system, or in the case of Oumuamua, it might kick it out of the solar system and go visit another solar system somewhere else. But once they get kicked into the inner solar system, then they start in a new orbit. And if they're close enough to the sun, then they become kind of the classic comet with a tail. Away from the sun, they look like a really dirty snowball. It's an ice rock mix, usually ranging to a few meters to a few hundred kilometers, depending on how big it is. But really far from the sun, there's no tail. It's only when it starts melting near the sun do we get an actual tail of a comet. And of course, the most famous one is Halley's Comet. The last approach was in 1986. It has about a 75-year orbit, so the next approach will be in July 2061, so mark your calendar. It's a little weird. We think this one probably got kicked into a different orbit, possibly by a passing star or maybe tugs from Jupiter. It's in a retrograde orbit, so it's orbiting the sun in the opposite direction that the planets orbit the sun, and it's at a really highly inclined orbit. So it's a little weird for a comet, but there it is. So you can see that it's this kind of rocky, icy thing, and then the tail comes off as it gets close to the sun. Now, since we're concerned about the survival of Earth, there was actually a scare in 1910 when Halley's Comet came by. It actually passed extremely close to the Earth, so close that the Earth actually passed through the comet's tail. And this is around about the same time that astronomers started doing spectroscopy and discovering the chemical elements that are in stars and planets, and really finding out what the stars and their solar system was made of. And so they turned their telescopes to Halley's Comet and discovered that the tail of the comet contains cyanide. And here's the Earth going to be passing through the tail of the comet. So there was a panic. No word on if there was a run on toilet paper or not, but there was a panic. People were actually selling comet umbrellas. I don't know what that was supposed to do, but always making a buck from someone. Turns out that everything, of course, was fine. The density of a comet tail is extremely low. The nucleus of a comet is extremely low, let alone the tail. And it's 80 to 90% water. And so the amount of cyanide, I mean, there's more cyanide in the atmosphere we're breathing than the actual comet. So was not an actual problem, but of course it made headlines and was a huge panic at the time. So we have been visited by asteroids and comets in the past. There is some controversy as to how we got water on the Earth. And for a long time, it was thought, oh, well, comets have water. So the Earth got bombarded by a bunch of comets. They melted and made our oceans. The problem with that is most of the comets, with a few exceptions, like Comet Hartley 2, do not have the same isotope chemical ratios that we see in the ocean. So they have a different type, different chemical composition to their water than we actually see. Our ocean chemical composition actually matches what little water there is in asteroids. And so now it's thought that maybe it was the asteroids that actually brought water to Earth. It's still an open topic. We're not sure. So comets are fewer, but they have a lot of water. Asteroids are plentiful, but there's very little water in them. So it's a trade-off, maybe some of both. This is still an ongoing and active area of research. There was a mission to a comet that was quite famous a few years ago, called Rosetta. And it woke up, got launched in 2004. It woke up 10 years later after being in a powered cycle sleep. This is kind of interesting because when I was working at Southwest at the time, I had some friends that were a part of this mission, and their offices were just down the hall from me. And so I was in the office this January afternoon, and all of a sudden down the hall, I hear a woohoo because it had turned on and everything was working. So the Rosetta team down the hall was very happy. So I knew it had come back to life. It had a lander that was also landed in November later that year. Sort of. It crashed and didn't really work, unfortunately. And the whole mission ended a few years later after that. But Rosetta gave us some wonderful pictures. And turns out it looks like this comet looks like a duck. It looks like a rubber ducky. So it was referred to as the rubber ducky for a very long time. And we thought this was actually a weird shape at the time, but then turns out 2 of Pluto's moons, very small moons, also have this shape. We've seen several asteroids now that also have this shape. So maybe it's not a weird shape after all. And so there's a lot of now discussion as to how do you get a rubber ducky shape out of things. And especially since the chemical composition of the 2 parts, the head and the body, are very different. So it looks like these 2 things stuck together early on in the solar system, and now it's traveling as one component. So here's some high resolution images, and here's the Philae lander from Rosetta and where it touched down. So it was looking down as it landed. Unfortunately, when it landed, it bounced and went to sleep. And then it woke up briefly, but it was on its side. So the radio dish to talk to it was kind of buried. And so it ended up being declared dead at that time, unfortunately. But the mission overall was a very good success. So we have these great high resolution images of this comet. It's just flying a few hundreds of kilometers. And there's even some images out there where it's just even a few kilometers above the surface. So as I said, when a comet is close to the sun, it becomes active and you get this tail. It does it through sublimation. So if you've ever played with dry ice and water, you've seen this smoke coming off. It's the same kind of process that causes a comet's tail. There are 2 main tails. It's not just this bright dust tail that we tend to think of as a comet, but there's also a blue ion tail that's very light. It's made up of just ion particles. So just individual elements, not even like particles of dust. And it tends to be blue and point directly away from the sun. So dust and ion tails always point directly away from the sun. They don't point in the direction of comet motion. They're always blown back away from the comet by the solar wind. So it has 2 tails. And so this is kind of a challenge to any astrophotographers out there, because if you ever see a bright comet in the sky and at a dark place, go see if you can find the ion tail. The white dust tail is, pretty ubiquitous for a comet. It's kind of when you think comet, that's what you're thinking of. But off to the side, there'll be this really faint blue ion tail. And if you can get into a really dark place with a really nice comet, you have a chance of trying to find it. And so when this comet that Rosetta visited got close to the sun, then it also started getting a tail. And the tail started coming off of the neck of the duck, actually. It didn't come off from near the head. It actually came off from this kind of pinch point between the 2. So that was kind of interesting. And so as a comet nucleus disintegrates, that's how we get our meteor showers. So when you have a single meteor flying through the Earth and you're seeing a single shooting star, it's probably a rock, came from an asteroid or another a meteoroid. But when you have a meteor shower, these came from a comet. And so it's the debris of the tail that the Earth is passing through or nearby. And they happen very regularly. Perseids and Leonids are a couple of famous ones, but there's many others. So you're just seeing we're seeing the debris from past comet interactions and remnants of the tail that are now in the comet orbit that the Earth is passing through. And they all look like they come from a single point, and that's why they're named after the constellation that they radiate from. It's called the radiant. So the Perseids radiate from Perseus, Leonids radiate from Leo, Orionids radiate from Orion, etc. The tracks, so they look like fanning out from that single constellation, but in reality, those tracks are parallel. So it's like a train track. If you look down a train track, it looks like the two edges of the track merge in the horizon. But it's the same type of optical illusion with these meteors flying through the sky. They all radiate back to a single point along the distant horizon. So if you want to learn more about meteor showers, there's a really nice article in Stardate about it, and it has a calendar of when all of the meteor showers are. Now, I know what you're thinking. That's all very interesting. But when is a giant asteroid going to hit the Earth? Okay, so a couple of things. So most asteroids live in the asteroid belt between Mars and Jupiter. Most comets are really far out and have orbits that are really far from the Earth. So comets are usually, with an asterisk, not an issue. So it's the asteroids that we typically worry about. There's different categories of asteroids that we are concerned about. And as a class, they're either called near-Earth objects, or NEOs, or potentially hazardous objects, or FOs, or maybe even near-Earth asteroids, known as NEAs. I don't want to get too bogged down in all the terminology. They're given these names of Amor, Apollo, and Aten, depending on whether they cross Earth, cross Mars, or cross both. So the Apollo and Aten ones are the ones that we're very concerned about. So these actually have orbits that intersect with Earth's orbit occasionally. So these are the ones that we have to worry about. And we have been hit by large stuff before. We think that's how we got our own moon. The current theory of how our moon formed is that 4.5 billion years ago, there was a giant collision with a Mars-sized object running into a much larger at the time proto-Earth, and then the coalescing material formed the moon. It was not really a direct impact like this kind of artistic cartoon picture. It was probably more of a side swipe. And so that impactor then grazed off material from the Earth. It ended up going into orbit around the proto-Earth and then recoalesced into what is now our moon. We think this is the case because our moon is quite large for the planet. Usually when you have a ratio of planet to moon size, the planet is significantly larger than the corresponding moons in the solar system. And our ratio is much more balanced. So we think this is why it was some sort of capture event instead of just debris of formation forming the moon, like you would see with a lot of like the smaller Jupiter moons. And the evidence for this is that the core of the moon is kind of made of different material than the Earth. So we think that's the remnants of this impactor. But the crust of the moon is identical to what we see on Earth. So that suggests that that material then was swiped off of the Earth and then recoalesced around the moon. And they're both the same age. So both of these things solidified together and were definitely formed in their current state together. Now, the only other terrestrial planet, the inner planets to have a moon, is Mars. Mars has two. Venus and Mercury do not have moons. So it's kind of weird for terrestrial planets to have moons anyway. It's usually the big ones that have moons. But Mars has two. And if you notice, Phobos and Deimos have this kind of lumpy, bumpy potato shape. These were probably just captured asteroids, and they're very small. They're only a few, like 10 kilometers or so, a couple, 10, 20 kilometers. So these are probably asteroids captured from the asteroid belt. Remember, the asteroid belt's between Mars and Jupiter. So capturing a couple of these is not a crazy idea of just capturing a couple of asteroids. And now they've been glorified to moons. So Deimos and Phobos orbit in very different orbits. So Deimos is much, much further away from Mars. And Phobos is actually quite close. Phobos is actually slowly spiraling into Mars. It's going to impact it at some point. So all of these images are from the Curiosity rover. And so you see this kind of eclipse or transit of, if Deimos was much, much larger, these would be solar eclipses in the top. But Deimos is far away from Mars. So you just see this tiny thing going across the sun. Phobos is much, much closer to Mars, so that makes it look much larger. And so you see this large thing crossing in front of the sun. And then the bottom movie is actually Phobos going in front of Deimos in real time. That's not an accelerated image. That is Curiosity actually taking images and then having them spliced together as a movie. But the timing sequence is actually in real time. So that's Phobos transiting Deimos. So how do we know something is going to hit the Earth or not? And there's this scale called the Palermo Technical Impact Hazard Scale. And it's similar to the Torino scale. If you've paid attention to Armageddon or Deep Impact or any of the other movies, they usually go off on some science jargon tangent about the Torino scale. And so the Torino scale is how likely is something going to hit us plus how much damage is it going to do when it does. The Palermo one is just, is it going to hit us or not? And it's not talking about how much damage it's going to do. And this is the one that's typically used more often in maybe more scientific circles. If the value of an asteroid has a value that's positive, it is a likely impact and should be a very high concern. Values that are kind of -2 to 0 are labeled as concerns. So these are things that could impact us in the future and could move into a positive value at some point. So we don't have any asteroids that have positive values right now. That was not true at one point. So Apophis is probably the most famous one. It was discovered in 2004. And when it was discovered, it had a number of positive 1.1 with a 2.5 or 2.7% chance of hitting the Earth in April of 2029, which caused much concern because this is a large asteroid. This may not be a global killer, but it would definitely destroy a city, perhaps. So this is a problem. That collision was then ruled out. Better orbital models were calculated, more observations were taken, but this has a 7-year orbit. And so there was concern that when it came back around in 2036, it may actually collide. Then that has now also been ruled out. And as of last March, there is no chance of it hitting us for the next 100 years. So we're good on this one. It's fine. But it is going to pass extremely close in 2029. I do note that April 13th in both 2029 and in 2036 are on Fridays. They are both Friday the 13th. But it is going to pass very, very close. How close? It's going to be just over 31,000 kilometers above the Earth's surface. The moon is 400,000 kilometers away. This is within the geobelt of the satellites. And I saw one report that said the estimated magnitude on close approach is going to be 3.1, which is definitely naked eye visible. Now, caveat to that, this is like a comet. We don't really know. And you hear all the time about the comet of the century, and then it ends up being nothing. So I don't know how bright this is going to end up being, but being that close, it's going to be pretty bright. So this will be really interesting to see worldwide. We don't get something this big passing this close that often. Another one that is of concern is Bennu, and we've sent a mission to Bennu before. So this is OSIRIS-REX went and visited Bennu. So you can see this is a very nice high resolution image of the asteroid. And OSIRIS-REX actually touched down. So there was a Japanese mission recently that also did a sample collect on a different asteroid. I'm not talking about that one. Bennu was the NASA one that also did a sample collect on the Bennu asteroid. So it has a value of -1.69. So this is a concern. There will be a close approach in 2060, but it will be twice the distance the moon away. So not too close. Its concern for impact potentiality is between 2175 and 2199. So ways in the distance. But it's a concern. Unlikely to hit during this time period, but it's a concern. So hopefully we'll learn more about it when the sample collect comes back. The sample collect from OSIRIS-REX, I think, lands in 2025. The spacecraft just left the asteroid and is making its way back to Earth with its sample of the asteroid. Now you're probably asking, well, which one is the worst one on on the list? Well, it's this one. It doesn't actually have a name, 29075. It was discovered in 1950, and it's a negative 1.42. Its year of concern is 2880, so don't lose sleep. But I will say that it is 1.3 kilometers big. That's a big problem. That's a big boy that's going to come by. So if this hit us, it would have global implications. So yeah, so this one is definitely a concern, but there is no prediction that it will actually hit us. Certainly not in our lifetimes, and probably not even in the year 2880 either. But it's one that we're keeping tabs on in case the orbit, because orbits can change. It gets tugged by Jupiter, it gets tugged by another asteroid, orbits change. So this is why we keep track of them. Now, when meteorites leave craters, the nice thing about Mercury, the moon, some of these asteroids, they don't have any weathering effects. So that gives us an indication of the age. The more craters there are, the older that it is on these places that have no geologic activity. So that's kind of nice. So you can make these big craters, and there's certainly examples of this on Earth. Even though we have weathering on Earth, if you have a big crater, it still sticks around for a while. Make these giant impact craters. So you can have these ejecta flying out. So you get these rays that go out from the crater. Usually there's kind of secondary material, these kind of nodules that are around the outside, and even making these secondary craters. And you'll often, on a big one, get these central peaks. So the material, the rock, when the impact happens, gets instantly molten and liquefies. And if you ever dropped a rock in the water, sometimes you'll see the center of the splash go up. And so the same reaction is happening here, where you have this molten rock making this peak, and then it re-solidifies. So the biggest crater that we've, and probably the most famous one, it was the one that destroyed the dinosaurs. So it marked a large extinction event between the Cretaceous and Tertiary boundary. And we've actually seen, we know where this crater is. It's actually in Mexico. It's the Chicxulub crater. It's quite big. Part of it is in the Gulf of Mexico under the water. Part of it is actually on land. And you can see that it's, here's the scale. So that's kind of the size of it. And so it's large. The asteroid that landed was probably about 10 kilometers big when it impacted. Now out west, you have the Barringer meteor crater. Maybe some of you have been to this one. This was an iron nickel meteor about 50,000 years ago. We've seen remnants of this one. Meteorites have been found. These iron nickel meteorites have been found within the crater. And you can also, and it's quite large, and you can see these kind of rays going away from it. So just like in my little cartoon diagram, and these kind of little nodules around the outside. So this is kind of a classic impact crater. Some other famous ones, just to show some pretty pictures. So we have one that's actually in Chesapeake Bay. If you didn't realize that there's a giant crater in Chesapeake Bay about 35 million years ago. There's another one in Siberia. Turns out Russia gets hit a lot. Siberia is a large area of the Earth, so Siberia gets hit quite frequently. And then we have these lakes that filled in. So there's one in Quebec and one in South Australia. These are also crater impacts. Now, fortunately, we have Jupiter in the solar system, and turns out Jupiter is big. And if a comet or a large asteroid is coming from the outer solar system, Jupiter's is massive enough, it gravitationally pulls in those things and kind of hoovers them up so they don't crash into us. So that's kind of nice. Jupiter is actually kind of a protector a planetary defense protector from outer solar system stuff. And then probably the more famous one is when comet Shoemaker-Levy 9 crashed into Jupiter in 1994. Some of these holes that were left, of course, Jupiter is a cloud surface, so it made a lingering hole actually in the clouds, and then it eventually covered back over, and it was no longer seen. But these holes that were made in Jupiter's cloud layer, some of them were the size of the Earth. So that would have been bad if it hit us. So thankfully, Jupiter does hoover up a lot of these things and actually protects the Earth from getting hit. There's actually an asteroid impact on Jupiter as well. And so this is my plea to all of the amateur astronomers to be like, Jupiter. We have seen Jupiter before, who cares? So it's going to happen over here, kind of off to the right side, and there's a little flash. It replays in a little bit slower. But you never know. This was actually recorded by an amateur astronomer in their backyard. There's a flash off to the right. And so this was an asteroid impact that was happening on Jupiter, and it was captured in real time. So yeah, so there's the flash. So you never know. And so this was done in Austria on just an 8-inch telescope. So you never know what you're going to see watching the sky. Now we have been hit by a comet. This was the Tunguska event, which you may have heard of in 1908. Happened in, surprise, Siberia. So this was probably a comet, might be an asteroid, but probably a comet. But this one didn't actually impact it. The interior of the comet heated so much that it actually exploded in the atmosphere. And the blast flattened trees for miles and miles. It was quite devastating. Fortunately, it happened in Siberia, where there was really nothing. There was one report that one person may have actually heard the blast. He was some recluse guy with his family living in the middle of Siberia. They were not injured, and there were no injuries reported with this event. That was not true with another event that happened in Russia. So this was recorded by a dash cam video in 2013. This was a meteor. This was only about 20 meters across, so not a big one as meteors go. But it did actually injure about 1,000 people. Fortunately, nobody died. But it did hit this city and collapsed the roof of this zinc factory warehouse. And the impact itself, so it also exploded in the atmosphere, and they did find pieces of it on the ground. But the reason why so many people were injured is because if you're sitting at home and you see a bright flash of light out the window, what do? You run to the window to see what happened. And when this exploded in the atmosphere, the combination of the explosion and the sonic boom of it going through shattered the glass of all of the windows in the city. And so people standing at their windows got glass rained on them. And so it injured about 1,000 people from the glass shattering. So if you see a bright flash, remember, duck and cover, don't go to the window. Now, I was also asked to talk about a potential man-made impactors. And so this has been in the news recently. So this was a Chinese rocket. It was called Long March 5B is the technical name of the rocket. It's a very large rocket comparable to some of the large ones the US has. It launched a part of, so China is also building a space station similar to the ISS. And so this launched a piece of that space station. Now, the problem with the Chinese rockets is most countries, US, Russia, even India, I think, when they launch something, they leave enough fuel in the rocket so they can have a controlled descent and plan where that debris now is going to land. And they usually jettison it so it lands in the ocean. China has decided they're not going to do that. They're going to use up all of the fuel in the rocket, and it's going to land wherever it's going to land. So it has a completely uncontrolled tumbling reentry. And when you have something that is somewhat large, I say it's about 30 meters in length, and 21 tons empty, coming at you at terminal velocity, that could do damage if it lands in a bad place. Fortunately, the two that they have launched have both landed in the ocean. The one that was of concern last May landed in the Indian Ocean. There was a test a year ago in May, landed in the Pacific Ocean, but it did break up as it was re-entering. And there were some villages in the Ivory Coast in Africa that did have debris land on them. Fortunately, there were no injuries, but you do have this shrapnel basically rained down on these villages. So the international community has been pressuring China to change their policy, but no word if they're going to do that or not. So in conclusion, will a huge asteroid hit the Earth? The answer is yes. It's going to happen at some point. We're due for one, actually. One that kind of killed the dinosaurs hits us about every 50 million years, and it's been 65. So is it going to happen? Yes. Is it going to happen in our lifetime? Probably not. We're very much aware of where all the really big ones are, the ones that are global killers, the ones that could be city killers. We know where they are, we're tracking those, and those are being watched very closely. The big issue comes from these smaller ones, like the one that hit Russia in 2013. 20 meters, we can't track those. We don't see them. We don't know where they are. And there was no warning when that one came in. And most of these actually come from the direction of the sun. So we get grazed by them and then don't see them until after they passed us and say, what was that? And we do get grazed by something that large 3 to 5 times a year. They don't usually hit us. They just go by and it's fine. Occasionally we do get hit by one, and most of the time it lands in the ocean and we don't even know about it because it didn't impact anything at all. And it's only occasionally that you have something like happened in Russia where it actually is affecting property and life and people. So fortunately it's rare, but it is something that we should be concerned about. And that's all I have to say. So thank you very much.